Hi folks, so this video is called Predictions for 2023 Higher Level Leaving Cert Maths Paper 1. So underneath here I've got kind of smaller writing, so what has come up repeatedly in the last few years. So that's generally what I'm going to be focusing on. I'm not trying to guess here as to what the examiners are putting on the paper, the exact topics that they're just thinking of putting on it or anything. I'm just going to look at exactly what has come up for the last 4 years there, so 2022, 21, 20 and 2019. So first thing I want to show you is this. So it's a spreadsheet, and I've inputted these things. So if you look in the top left corner there, so question 1 and 2022, so a quadratic roots, b squared minus 4ac, so understanding that, so whether it's equal to 0, greater than 0 or less than 0 as to how many roots it'll have. So that's the general topic for that. For question A it's the same for question B, and then for C it's factor theorem and algebraic division in it. So that doesn't show you exactly what's being asked in it, but it shows you the overall topic. So I'm going to be looking through this, and I'm going to highlight to you things that are commonly coming up in each year. So generally things that have come up every year. So the idea behind the video is to give you, it's not, obviously there's going to be a lot more than the things I highlight later on here, but that will come up on the paper, but it should give you hopefully a starting point. Or if you haven't looked through exam papers before really, or you don't really know what usually comes up or the things that commonly come up and the way they're asked, it should hopefully give you a bit of an insight and a bit of a direction as to start your revision. So these are the general topics that are on paper 1. So this is only going to focus on paper 1 now. So you'll see something like trigonometry isn't there because that is on paper 2. So that's a given that will be on paper 2. So you don't have to worry about it on paper 1. So paper 1, algebra and functions, complex numbers, calculus, sequences and series, financial maths, and area and volume. So they're the overall topics. The first one that I want to look at in a bit of detail is the calculus, so differentiation. So differentiation is really big on paper 1, and it's something that you have to know going into the exam. So the first 3 of them here, differentiating a basic function, differentiating a function with the natural log, and differentiating a function with e, they're pretty much all similar enough. It's just there's slightly different slight differences in how you differentiate those things. Now you could be asked to differentiate a trig function as well. I haven't put that in, but you'll need to know that as well. I don't know why I didn't put it in. Differentiating to find a max or a min, so that's understanding that when you differentiated, you let the answer equal to 0 because you know that the slope has to be 0, and solving from there. Finding a point of inflection, so that's done with the second derivative, so differentiating it twice and using the point then, and differentiating by first principles. So these are all things that come up with calculus. So they're all, they're all straightforward enough. There's a definite way of doing each one of those things. So if you learn it off, you should get the marks easy enough. It shouldn't be the hardest thing that's on the paper. What I'm going to go through here. So I'm just going to show you a question really quickly on each of them. So the first thing, differentiating a basic function. So this came up. Oh yeah, sorry, I want to show you this first. So if you go back to the spreadsheet here, I've highlighted in red all the places differentiation comes up. So again, and there's nothing scientific really behind this spreadsheet or anything. I could even have missed a few things here and there, and they're more or less the things that I've called them. I haven't got this off the state exams website or anything like that. They're not officially. It's just me looking at each thing and categorizing it myself into words. So it might not be 100% precise and exact or whatever. But in red there, I've highlighted everywhere that differentiation is coming up. So if you look at 2022 alone, it's coming up in question 5 and question 6 and question 7 and a little bit in question 10 as well. So every year it's coming up multiple times there, you see. So I'm going to show you an example of a question there for the first thing that we had, that was differentiating a basic function. So here you have, so you have to differentiate that 2x cubed plus 6x squared minus 12x plus 3. So you're just dropping down the power and multiplying by the power and so on. Now in this one they throw in a little bit of a twist. You have to represent it in, you have to complete the square and represent it like this. So that's just completing the square really, along with differentiate. And then the second part is you have to differentiate that g of x, so 36x plus 5, so that'll g dash x there will just be 36. So you just have to let your answer to the first thing be greater than 36 and solve the inequality then. So obviousthere's going to be twists thrown in. It won't be just what I've got down there, but that's just an example of where it came up. So 2021 question 5a, differentiating a function with natural log. So here is a function with the natural log. So 2022, I'll put links to the answers. So I've got a lot of videos with solutions on, so I'll put links at the bottom to as many of these as I can. So 2022 question 10c, this is an example of where differentiating a function with the natural log came up. So part C1, you just have to differentiate it, and then you have to just sub in 1 in for t in this case, and that's your answer really. And then what does it tell you? So the second part is just explaining the context of it. Okay, so differentiating a function with e. So again, similar enough, it's 2021, so I'll give an example here, 2021, question 9c. So 75 e to the power of minus 0. Can't even see that there. Minus 0.081 t. And then you've got plus 20. So then, so it's similar enough again. It's just subbing in at the end. Differentiating to find a max or a min. So the important thing here is just understanding that you need to just differentiate it as normal. So you're going to differentiate that function and then you let it equal to 0. So the reason you let it equal to 0 is because that's where the slope will be 0. So if you have a max on a curve, something like that there, the tangent will be a straight line. So the tangent will be equal to 0. So the slope will be equal to 0. So you let it equal to 0 and then you just solve from there. And you can sub back into the equation, the original equation, then to get a value for y if you need to. Point of inflection. So to do the point of inflection now here, from this video you've got, so the function is f of x equals x cubed plus kx squared plus 15x plus 8. Now they do give you how to find out what k is in one of the earlier parts. So this is part C of the question. Should be C there actually. Yeah, so it is just differentiating the function twice. So you'll get the second derivative, so d2y dx squared. So that's what you need to find here. So it's the second derivative. So you're differentiating it and then differentiating it again, and then you'll let it equal to 0 then and solve, and you'll work out the x value, and then you can sub it back into the original function and get the y value. So that's just point of inflection. It's knowing that point of inflection is the second derivative. So it's easy enough. Wherever you see point of inflection on the paper, you should know that you just differentiate it twice. So it's fairly straightforward for marks. Differentiating by first principles. So that's your f of x plus h minus f of x over h, and then you have to do the limit as x tends, or h tends to 0, sorry. So that's just applying that. So you'll find f of x plus h first, and then you'll take away what f of x is, and then you put it over h. Then hopefully you should get a lot of things that cancel out. And then you'll do limit h at the end, and that'll just differentiate what that thing there. So that's just something you need to learn off how to do it and practice it. But it came up in 2020 and in 2022, so it's not coming up every year, but it's a fairly straightforward thing as long as you're okay on differentiating and all that, or subbing in and all that. It should be a straightforward enough thing for marks, so it's usually worked a good few marks when it does come up. Okay, the Myers theorem. So there's always going to be a complex numbers question on the paper. So if I go back here, yeah, so you can see the Myers theorem, something on it comes up pretty much every year. Now it's probably one of the things people find harder on the paper, and there's different things that can be asked on it. You can see as well there, that's the only thing I've put in this video now on complex numbers. But if you look at 2022 there, part A is complex numbers, letting real and imaginary parts be equal. The modulus, okay, so they're basic enough things with complex numbers. Then 2021, rationalizing the denominator came up. So that's when you're multiplying top and bottom by the conjugate. And yeah, there was a simultaneous equation on 2020. It was a little bit different than what you normally see. And there's geometric sequence mixed in there with complex numbers. And there was also rationalizing the denominator that came up a second time. And then for 2019, it was actually question 5 where the complex numbers come up. So using complex roots to form a quadratic. So different things come up there in complex numbers each year. But you're guaranteed a question. So there's only a certain amount of things that are in that chapter in your textbook. So you need to look through it. But the Myers theorem is the thing that's common that you need to have a good understanding of. So there's 2 questions here. So that's 2021 question 1C and 2022 question 3B. So that 2021 question, you'll represent that minus 8 as a complex number. So minus 8. So minus 8 will be around here. So you'll be able to represent it in polar form. It'll just be cos of pi plus I sine pi. It's pi because it's just a 180, so pi is around here. And then so z cubed is equal to that, and then you can bring over the cubed and you can represent it as 1 over 3, and then you'll be using the Myers theorem after that. And they're asking for 3 roots here, so you have to sub in 0, sub in 1, sub in 2. So I'll try to put up the solution to that underneath, a link underneath. I'll go through it in more detail. The 2022 question 3B, yeah, so you're going to be representing that root 3 minus I in polar form first, and then you can apply the power of 9 using the Myers theorem. Okay, so that's that. This average value question, so this is an example of it in 2022 question 8F. So h of t is equal to 72 minus 60 cos pi over 3 t. So this is integration really. Now this is the only integration that I've put into this video, but integration comes up a little bit more as well. So you could be asked to just integrate a function, but this has come up every year actually. And it's fairly easy to see because it'll always mention the word average, so average height of a point, and it'll always give you a function to use the formula in. So you need to know this formula. But if you look back here, so you see there question 8F question for 2022. For 2021 it's 8C. For 2020 it's question 9C, and then for question 9 or for 2019 it's in question 8 again. It's at the end of question 8. So it's come up there every year. So something that it should be fairly straightforward. So you're just subbing in, so B and A. So the question is here, it's over the first 8 minutes. So your B and A here, so it'll be 8. So B would be 8 and A would be 0 because your A is just the start. It's 0 minutes. And then it's the integral of, and you have to use 8 and 0, and it's that function, so 72 minus 60 cos pi over 3t. Yeah, so you have to be able to integrate that function, obviously. So similarly with differentiating, you need to be able to integrate things with cos and things with e and things with natural log, so they commonly come up. But it's just applying that formula really and being able to integrate it out, and there's not too many places you can go wrong from there. Right, so next thing, so subbing into function to fill table and then drawn on a graph. So this type of question, this is one of the easier things that are going to come up that on the whole paper. So in the long questions, so questions 7, 8, 9, and 10, this always comes up. Well, not always. I think I didn't see it there in 2020. But it came up for question 8 in 2022 and in 2021, and it came up back in 2019 as well. It's just where you're given a function, and all you have to do is just put it into the calculator, and it's mostly calculator work, and you're just filling it into the table. So an example of it here, 2022 question 8. So it's a thing about a Ferris wheel, and this question will get a lot harder in part B and part C, but the first bit you should be getting these marks easily enough. So here the function is h of t is equal to 72 minus 60 cos pi over 3t. That's the same thing I had for the other thing, for the average value actually. So all you have to do here is you just have to put in what it is instead of t. So the first thing you'll sub in that function into the calculator. You'll put in 72 minus 60 cos pi over 3, but then instead of t you'll just put in a 0, and then keep sticking your answer and just put your answer in underneath. Then you'll do the same, but you'll put a 2 in instead, and you'll do the same, but you'll put a 3 in, a 4 in, and so on, and you'll just get your answer. So that's one of the easier things that's going to be on the paper. Then that's generally followed up by something like this. So draw a graph of y equals h of t. So all you're doing is you're taking your things from the box, so whatever values, you're just plotting them on it. So whatever you got for 0 down here, you'll go to 0 across the bottom, and you'll put a dot on it. So you'll get some kind of a curve there in the end. Right, next thing is geometric sequences. So there's a good few things that can come up here with geometric sequences. So these are the places that it's generally coming up. So It came up in a good chunk of question 9 there in 2022, question 7 in 2021, and then it came up is question 5b, so sum of a geometric sequence in 2020, and a little bit in part B of question 2, and then it came up in 2019 again. So there's a few formula that you need to know for geometric sequence. And they're all in your log tables. Now, first part of this again is just filling in the tables, like the thing I just showed you last time. But the longer questions are generally easy enough to. There's generally a kind of a way of, or a process involved in them. The first bit might be a table, or it'll be a function, or it'll be subbing in, or something like that. So they give you the general. So the first part you're just subbing in, filling in the table. Second part, they give you the general term. Actually, you don't even need to work that out. And you're just going to be subbing into it. Now the third part here, it's asking you to find the total distance. So when you see something like that, total, the word total is highlighted. That's going to be a hint to use the sum formula. So the sum for a geometric sequence. So it's a to the 1 minus r to the power of n over 1 minus r. It's that one. So it's in your log table. So you just look for the sum of a geometric sequence. Then I think somewhere down here as well, B, if you look at B part 3 there, it has total distance. So total distance will be your sum to infinity formula. So again, that's in your log table. So it's just using that and applying it to the numbers that are there. It goes off. So part B is more to do with the arc. So you'll get a different type of geometric sequence for this question. But I'll put a full solution in as well underneath for this question, so, or link to it. So but the formula there that are in the log tables would get you a lot of the way through these questions. It's just practicing these types of questions and being familiar with them and the way that they're asked. But that's a real possibility. Geometric sequence, that's a real possibility for the last 4 questions for 7, 8, 9 and 10 on the paper 1. There could be something like this in those. Right, so I've only got a couple of things left. Proof by induction. So this came up in 2019, 2020 and 2021. So you start that by letting letting n be 1. So here if so show true for n equals 1. So therefore to be 2 to the power of 3 times 1 is 3. Take away 1, and then plus 3. So that's 3 take 1 is 2. So 2 to the power of 2 minus 3. Sorry, plus 3. So that's 4 plus 3. So that's 7. So 7 is divisible by 1. And then you assume true for n equals k. So that'd be 2 to the power of 3k minus 1 plus 3, and then you show that it's true for n equals k plus 1. So there's a definite way of doing these. It's just learning it off and learning off the different types of ways that it can be asked. But I'll put a solution again underneath, or link to a full solution underneath for that, where I explain it a bit better and in a bit more detail. But that came up in, it didn't come up every year, but it came up in 19, 20 and 21. So it didn't actually come up in 2022, or well, I didn't see it there for 2022 anyway, unless I missed it. But it's probably primed then to come up this year in 2023. So something again that you need to know going in. Okay, so factor theorem. Factor theorem is generally comes up fairly early in the paper. Now this is the 2020 question 1. I'm pretty sure. Yeah, so factor theorem, so it's generally understanding. So if you had something like that x equals 1, that if that was a root, well then x minus 1, the opposite sign, that's a factor. So it's understanding that really, and being able to apply it. So here, find the value of p for which x plus 3 is a factor. So what you need to know, that if x plus 3 is a factor, well then x equals minus 3, that has to be a root. So if it's a root, then it should satisfy the equation. So if it's satisfying the equation, then you can just sub it in, so, and let it equal to 0. So minus 3 squared plus 5 times minus 3 plus p is equal to 0, and then you can just solve it out and move across and see what p is. So that works out the value of p for that. Now the second part, so it's x squared. You know that the sum of the roots has to be in here, x, and then plus the product of roots has to be there. So you could let your two roots at the start be y and y plus 3, because you know that there has to be a difference of 3 between them. So when you add those two things together, then you should get 5, but when you multiply them, you should get p. So it's just using that to solve it out. Last thing that I'm going through. So 2021, it's 3b, and 2021 9b, so it comes up twice there in the same year. So I'll just show you again. Yeah, it's fairly common through the paper, and this actually comes up in other types of questions even throughout as well that I haven't got highlighted here. But it's using logs to solve when the variable is in the power. So yeah, so first thing for the 2021, so 3b question, it's a quadratic. All it is, it's a quadratic that you have to solve first of all. So when you factorize out this, you get 3x minus 7 and x plus 5 equals 0. So then when you solve it from there, you'll get x is equal to 7 over 2. No, 7 over 3. And x is equal to minus 5. So you get two answers. You get 7 over 3 and minus 5. But then the next part, it's actually the same thing. That's the same quadratic there as the first part. It's just excuse me. It's just that instead of x, it's a 3 to the power of m. So all you actually have to do for the second part is you let 3 to the power of m be equal to your two answers for the first part. So 7 over 3 and 3 to the m equals minus 5. So you can actually get rid of this, because power of m can't be a minus 5. So you only have to solve this, but this is where this topic comes into it then. So solving with a variable in a power. So here we have an m in the power. So it's not like, something like if you had 2x equals 10 or something, you can just divide across or whatever. So when the variable is up in the power like that, you have to use rules of logs. So in this case, easiest thing is use so log to base 3 to the m is equal to, so you're just basically putting log to base 3 in on both sides, and then so log 3, when you have this here, the base and the number being the same thing, then you can let it equal to 1, so that will just be m. So on the left hand side you'll just get m, running out of space here now, but you'll just get m is equal to, and then all of that on the right side basically, but you can go straight and put that in the calculator if you want, or you could break it into log base 3 7 log base 3 3 on the bottom, and that'll actually be a 1 on the bottom as well, so it'll just, your answer will just be log 7 to base 3. And take away 1 because they actually want it in this form, in here, m equals log base 3 p minus q, so log 7 to base 3 minus 1, because log 3 to base 3 is 1. And that's just another rule of logs there that I've used. So part B, so 2021 9b, that's where you're going to let it be equal to 82, so you're just letting that 82 be equal to 75e to the power of minus 0.081t plus 20. You could bring the 20 over straight away and subtract it, so you get 62 is equal to 75 e to the power minus 0.081t. You can bring the 75 over and divide it, so 62 over 75 is equal to e to the power minus 0.081t. Now the reason I want to put this in as well is because you've got an e here, so what you'll have to do is you'll have to put an ln on both sides, so or natural log, so you'll get natural log 62 over 75 is equal to natural log e to the power of minus 0.081t. So what happens when you've got natural log of e, they'll kind of cancel each other out, so they'll just be 1, so you'll get minus, you'll just be left with minus 0.081t on the right hand side, and you'll still have your natural log 62 over 75. So it's easy enough to bring across the minus 0.081 then and divide it. So that's again where the variable is up in the power, and it's just a little skill there that you need to know and need to understand to be able to solve things like that, and that comes up throughout the paper. So that's the last thing I really wanted to show you, but I'll put proper, so some of those I was rushing through solutions, or I didn't do solutions for a lot of them because it would have taken this is a long enough video already. It's over half an hour, so it would have taken well over an hour and a half probably if I was going through all of these solutions specifically. But I have links to them. I'll put links below to all of these questions that I've gone through. Everything I think in this video I think is something that you should know going into the exam and know how to do it. So I'll put links below to any of the questions I have that I have solutions to online. So again, just to re-emphasize what I said at the start there, it's not about me trying to predict exactly what's going to be on the exam, but it's just showing you a lot of the common things that are coming up, and a lot of the common like everything I've went through there has come up pretty much every year, and it's something you just can't go into the exam without knowing. There's a good bit I went through there, but again, there's a lot more going to be on the exam. Hopefully this will give you kind of a starting point as to what to be looking over. But once you've got all that stuff looked over that's in this video and you understand generally how what's going on and how to do them, then the advice any teacher will give you is to look through exam papers and do more and more. Like, the more questions out of exam papers you can do, the better prepared you'll be for the exam. So ideally, I'd be saying try and get 3 or 4 years fully all the exam questions done and written into your exam papers, and understand them for the most part as best as possible. And you should be very well prepared then if you're able to do that much. So the reason I put this video up here is because I always get asked, or when I'm tutoring students, and in particular asking me what generally comes up, what should I be focusing on. These are the things I think are commonly coming up. There's probably things I missed there, and there's probably extra things that maybe there might even be something really obvious that I didn't put in, I'm not sure. But generally that's what I think is important for Maths Paper 1 for 2023. I'll put links below to most of those questions, anything I have, so look through them in more detail, because I'll put links to videos where I'm going through them a bit better and a bit more detail, because I'm rushing a lot of them there and I wasn't explaining some of them too well. But that's it.